This is topic 5 homework problem number 13. And what we have is a canal that turns a right corner, and we know that this distance is 4 meters across here, and we know that this distance is 4 meters across here. And we have two boards, and each board is 3.9 meters long. So we know that we can't just, what our goal is to cross the canal. I assume from here to here. Okay, so I assume that we're crossing from here to here, and we see that this board, 3.9 meters, is too short just to go across the canal like this. So we're challenged that when we have two of these boards, can we make a bridge to go from here to there? The first thing we recognize is that when we have this right angle, and I'm talking about this one right here, that we can put one board across it like this. And if we work carefully, then we get a right angle here, which we're going to have anyway, but we can then try to aim this to be a right isosceles triangle. And we want to know what the distance is from here to here. If this is our 3.9 meters, and this is a right isosceles triangle, then we know the 3.9 meters is the same as x square roots of 2. So that tells us that x is 3.9 divided by the square root of 2. And when we run that through the calculator, we get 2.76 meters. So we know this length is 2.76 meters. I'm sorry, this length here, 2.76 meters. So now we have, for our canal, we have a board across here, and it's at most 2.76 meters. Okay, you're going to place the board so it doesn't, if it's exactly 2.76 meters, the board might fall down into the water. So you might pull it in a little bit closer, but you don't need to pull it in very close, just enough that it rests on each side of the canal. So we could walk across from this corner to that corner across this board. And when we do so, we can take the second board and we can put it across this way. This corner here, this inside corner, is the closest distance to the first board that we put down. So we put the second board down, and we don't need nails to hold them together because the second board is resting on the first board and on the corner. So if this distance is a maximum of 2.76 meters, then we can use that to calculate the distance from here, this corner, to this first board. And then when we know that distance, we can see what the remaining distance is across here. And if it's less than our 3.9 meter length, then we can put our second board on the first board to that corner. So what we want to do is we want to find two things. We need to know the length of from this corner to that corner, which is a right triangle. And we know that the canal, so we got it here, the canal is 4 meters wide there and 4 meters wide there. So we know that this is a right isosceles triangle. So this whole distance from this corner to that corner is 4 times the square root of 2, which is about 5.6 meters. So if we find this distance here, we subtract that from this distance here, and that gives us that distance there. So what we need to do now is recognize that if I draw this diagonal all the way through, that we get a right isosceles triangle here with the hypotenuse being 2.76 meters, and these guys, we'll call them Y. And so Y is going to be 2.76 meters divided by the square root of 2, which is about 1.95 meters. So now we know this distance is 1.95 meters, and we know that this whole distance is about 5.6 meters. So we subtract the 1.95 from it, and we get the remaining distance across. When we do that, we get 3.65 meters. So we know that this distance is 3.65 meters. That's shorter than our 3.9 meter board. So we know that we can put one board across here and one board across there, and we'll be able to cross our canal. So yes, it is possible to make a bridge across the canal if you have only two boards, each at 3.9 meters and no nails. You just put one board here and one board across there, and you can walk across.